Here at UNC Charlotte, all sophomores have to machine these little air engines to orient them with the machine shop. So, compressed air comes in here, that side port. The cylinder has a hole in the other side of it, and it wobbles to intake the air and then exhaust it out the back. So it does that, and the way they're tested right now is they're fed 80 psi, and they count the highest RPM it achieves, and they also see how low of an RPM they can run the air pressure on. But you don't get very much information about how the engine is performing. So what we did as our senior design project was we made a dyno. It's an inertia style dyno, so we know the inertial load here. We measure the acceleration of the inertial load with our Hall effect sensor in the back here, and that gives us torque output. We also have an orifice plate and a pressure regulator down below. That is the pressure regulator, orifice plate, and we measure the pressure drop across the orifice plate with our pressure transducers here, and that gives us torque measurement, RPM, airflow, and air pressure, so you can plot all that data against each other and get a better feel of how the engine is performing. We wrote software that outputs RPM, torque, and power instantaneously, and you can electronically regulate the pressure, and it also outputs torque in inch-pounds, foot-pounds, and power in horsepower and watts. That it outputs all that to an Excel spreadsheet, so you can plot everything against each other. Here's the back side of the program. It's pretty simple. It just has changes our Hall effect sensor into frequency and does a bunch of cool stuff with it, and then outputs it to a file. The engines attach via a magnetic coupling. So there's a magnet in the center there, and when you put it in, since the flywheel is steel, it's a slip fit over the flywheel. The external dimension is a mil tolerance, so it's pretty tight. It's a tight fit in there, and then you just clamp it down. So it fits in there nice and tight. Clamp it down, and then you start the run. But it's always pertinent to put our blast shield up.